Hello and welcome to Algebra 1, Lesson 34. In this video, we're going to learn about dividing polynomials. So in the last lesson, we kind of got started with dividing polynomials. We learned kind of the simplest case where we divided a polynomial by a monomial. So I want you to recall that if you had something like 6x squared minus 2x, and we divided this by 2x, remember, we could write this as a fraction. So 6x squared minus 2x over 2x. And then we could split this up, right? Kind of using that same logic as when we work with fractions with whole numbers, right? This is a common denominator. So we could say this is 6x squared over 2x. And then instead of minus, I'm going to put plus negative 2x over 2x. Then we can simplify each part separately. So 6 over 2 is 3. X squared over x is just x to the first power. And then negative 2x over 2x, this would just be negative 1. So essentially what I'd have here is 3x minus 1 as my answer. So let me write this as 3x minus 1. Now, another important thing. We know how to do that at this point. Remember, if I want to check, I take the quotient, which is this guy. I multiply it by the divisor, which is this guy. And I should get the dividend back, which is this guy. So 2x times 3x minus 1 should produce 6x squared minus 2x. So 2x times 3x is 6x squared. And then 2x times negative 1 is minus 2x. So we get that back exactly. All right, so that's not very difficult. Hopefully you have mastered the concept of dividing a polynomial by a monomial. Once you've done that, it's really not much more difficult to divide a polynomial by a non-monomial polynomial. So in other words, a polynomial that consists of more than one term. So for example, if I saw something like 8n squared minus 42n plus 10, and I divided this by n minus 5, what would I do? Well, I can't use the same technique. That's not going to work anymore. We need to turn to long division, right? So the long division that we used with whole numbers, we can use kind of a similar process for polynomials. So let me just do a really quick rundown with long division of whole numbers. That way it kind of refreshes your memory a little bit. Let's say I had something like 4,620 and I wanted to divide that by 5. Remember the steps for long division. You're going to take your dividend, which is this number off to the left. This is the dividend. And you're going to start by putting that, as we say, under the house. So here's your 4,620. And then it's divided by 5. The 5 is known as the divisor. And that goes off to the left. So once you have this set up, you recall we have that D, which stands for divide, M, which stands for multiply, S, which stands for subtract, B, which stands for bring down, and then R, which stands for repeat or remainder. And the way you memorize this, you say dad, mom, sister, brother, rover. Right? You think about the family, right? A mom and a dad, and then a brother and a sister, and a family dog. So divide, multiply, subtract, bring down, repeat, or remainder. So when we get to polynomial division, here in a second, it's going to be the same thing. There's a few slight differences, but basically we're following that format. So you start out by saying, how many times will 5 go into this leading term 4? Well, it's not going to, right? So what you do is, you kind of expand that selection and say, how many times will 5 go into 46? Well, 5 will go into 46 9 times. 9 times 5 is 45. Subtract and we get 1, right? So we did the division, then we multiplied, then we subtracted, and now we just need to bring down. So we bring down the 2, and then we repeat, right? So 5 goes into 12 twice. So we multiply. 2 times 5 is 10. Subtract, we get 2. Bring down, and then repeat. So now we divide again. 5 goes into 24 times. 4 times 5 is 20. Subtract, we get 0. Nothing else to bring down, so we're done. So we get 924 as the result, right? And that result is called the quotient. Let me label that. That's called the quotient. So we're going to follow a very similar process to divide polynomials. So go ahead and start out by setting this up in the same way that you did that long division problem with whole numbers. So again, this is your dividend, and this is your divisor. So this goes under the house. So 8 n squared minus 42n plus 10. And that goes under the house. And then off to the left, we have n minus 5. What's going to be different here? Remember your steps. You divide, you multiply, you subtract, you bring down, and then repeat or remainder. In the first step here, you're only thinking about the leading term of the divisor. So you're going to ask leading term into leading term. So you only want to know leading term into leading term. Okay, that's one of the differences. You're not including the minus 5 part there. Okay, so just forget about that. Now, what is this going to be? Well, it's just going to be 8n squared divided by n. That's all it is. You just need the answers to that question. So I always do that off to the side if I can't figure it out in my head. And it's easy to simplify this. We know that n squared over n would just be n to the first power. So this is 8n. So that's the answer. Now, just like with long division with whole numbers, I write my answer up here. But here's the main mistake that a lot of people make. And it's not that big of a deal, but I see a lot of students that will put 8n right here. It doesn't go there because you have to think about place value. This is where n squared goes. This is where n to the first power goes. And this is where n kind of to the power of 0 or just a constant would go. So we have n to the first power. So I'm going to shift that over here. I'm going to write my answer right here, 8n to the first power. And you can liken that to what we did here. I didn't write the 9 all the way over here in front of the 4 because this isn't 9,000, right? This is 900. And so we want to maintain place value even though we're not working with whole numbers anymore. So this is kind of where n to the first power goes. So that's where I'm going to put the 8n when I get that as my answer. All right. So now I want to multiply. So 8n times n is 8n squared. And I also want to multiply by the minus 5. So 8n times negative 5 is minus 40n. So that's the main thing to remember. Everything else is pretty much the same because when I multiply by everything. But when I do the division step, it's only leading term into leading term. So that's one of the things you just have to remember. And it's just one of those things you're just going to have to practice. And after you practice 10 or 15 of these, you're just going to remember. And then once I've done these two steps, the next step is to subtract. So I'm subtracting this whole thing away. Now, there's a few different ways to do this. What I always do, and what I'm going to do in these videos for a while, is I'm going to put parentheses around this guy, and I'm going to put a minus sign there. Now, you can do it this way. You'll say 8n squared minus 8n squared is 0. Negative 42n minus a negative 40n. Minus a negative is plus a positive, so that would be negative 2n. You could do it that way. Or you can put a minus sign out in front of these parentheses, and then you could just say, that's a reminder to remove the parentheses and to change the sign of each term. Okay, so this would be minus 8n squared. This would be plus 40n. And then I can add 8n squared minus 8n squared is 0. Negative 42n plus 40n is negative 2n. You're going to get the same answer either way. So it doesn't matter how you want to do it. Then after the subtraction, we bring down. So plus 10. And now, I can erase that 0. I don't need that. Now I can just do, again, the repeat step. So I go back up to the top. So it's leading term into leading term. Okay? I'm not involving that negative 5 there. It's always just the leading term into the leading term. So what is negative 2n over n? Well, we know that the n's would cancel, and I'm left with just negative 2. So negative 2 goes up here. Then I multiply. Negative 2 times n is negative 2n. Negative 2 times negative 5 is plus 10. Now we subtract. Now we know the same thing over itself is going to be 0. But for the sake of completeness, let's go through and put parentheses around this guy and put a minus out in front. And then that reminds me, hey, I need to change the sign of each term. So this will be plus, this will be minus, and then I can erase this. Just a reminder for me. So negative 2n plus 2n is 0. 10 plus negative 10 or 10 minus 10 is 0. So I get a 0 there. Nothing else to bring down. So this 0 tells me that I don't have a remainder. Now, let's talk about something else. We know how to check division. When I have my answer, when I have my quotient, all I need to do is multiply it by the divisor. So this 8n minus 2 multiplied by n minus 5, and that should give me the dividend back. So 8n minus 2 multiplied by n minus 5. It only takes a second to check. And, if you're doing your homework and your homework's graded, why not get the right answer, right? So 8n times n is 8n squared. Then 8n times negative 5 is minus 40n. Then negative 2 times n is negative 2n. Then negative 2 times negative 5 is plus 10. So this equals 8n squared. Negative 40n minus 2n is minus 42n. And then plus 10. So you can see we get exactly the dividend back. 8n squared minus 42n plus 10. All right, so that was pretty easy. Let's take a look at another one. So we have x squared plus 16 plus 10x divided by x plus 8. So one of the things I haven't mentioned yet is that each polynomial, when you're doing the division, has to be in standard form. So this is out of order, right? The 10x should be over here. The 16 should be over here. So when I set this up in long division format, I'm going to correct that. So I'm going to say I have x squared plus 10x plus 16, and this is divided by x plus 8. So if you see a polynomial that's not in standard form, you need to fix that. So for example, if this would have been 8 plus x, I would have flipped that and made it x plus 8. Right? So that's kind of the first thing you want to do when you're setting this up. Now, we just go through the normal way, right? So let me write this down again. We have divide, multiply, subtract, bring down, repeat, or remainder, right? Dad, mom, sister, brother, rover. So again, I start out by saying leading term into leading term, okay? I'm not involving that plus 8, okay? Not doing that. So what is x squared over x? We know that one of these would cancel with this, and I just have x to the first power. Again, this is the spot for x squared. This is the spot for x to the first power. This is the spot for a constant. So we're going to put our answer here because it's x to the first power. So that's going to go right there. And then we're going to multiply. Remember, when I multiply by everything. So x times x is x squared. X times 8 is plus 8x. And then I subtract. I subtract this guy away. Now, you can do it like that, or, again, use this as a reminder to put a minus here and a minus here, and then you can remove all the parentheses and you can add. Either way you want to do it. X squared minus x squared is 0. 10x minus 8x is 2x. Now we're going to bring down, so plus 16, and then we're going to repeat. So we go back up to the top. So we're going to go leading term into leading term. So what is 2x over x? Well, the x's would cancel, and I would just have a 2. So plus 2. Again, multiply. 2 times x is 2x. 2 times 8 is plus 16. So we could see we wouldn't have a remainder here, right? Anything minus itself is 0. But again, for the sake of completeness, we're going to subtract this away. So I'm going to change the sign of each term. This will be minus, and that'll be minus, and then I can erase this. 2x minus 2x is 0. 16 minus 16 is 0. So again, there's no remainder. So our answer here is x plus 2. So x plus 2. And it's very, very easy to check. So again, if I wanted to take the quotient, x plus 2, and multiply that by the divisor, x plus 8, I should get my dividend back. X times x is x squared. X times 8 is plus 8x. 2 times x is plus 2x. 2 times 8 is plus 16. So if I combine like terms, I get x squared plus 10x plus 16, which is exactly this. It just looks a little different because this is not in standard form, and this is. Right? But if I flip the position here of the 10x and the 16, I would get exactly that. All right, let's take a look at one more where there's not a remainder, and then I'm going to go through what happens when there is a remainder, and we'll just look at one example of that. So we have negative 6x to the fourth power plus 29x cubed minus 5x squared minus 43x plus 10, and then I'm dividing this by 3x squared minus x minus 5. All right, so let's go ahead and set this guy up. So this is my dividend. So that's going to go under the house. So negative 6x to the fourth power plus 29x cubed minus 5x squared minus 43x plus 10. Again, that goes under the house. And then off to the left, we have 3x squared minus x minus 5. So again, let me write the steps up here so we don't forget. So we have divide, we have multiply, we have subtract, we have bring down, and then we have repeat or remainder, right? Dad, mom, sister, brother, rover. So we start out with the first step, leading term into leading term. So 3x squared into negative 6x to the fourth power. So negative 6x to the fourth power over 3x squared. So this negative 6 will cancel with 3 and give me negative 2. X to the fourth will cancel with x squared and give me x squared. So negative 2x squared is the answer. Where am I going to write that? Am I going to write it here over the x fourth spot? No. Am I going to write it here over the x cubed spot? No. I'm going to write it over the x squared spot because that's where it goes. So negative 2x squared. All right, now I'm going to multiply. That's my next step. Let me erase this stuff. And let me scroll down a little bit. And I realize it's going to take this guy off the screen. So let me kind of drag this down right there. And let me scroll down a little bit. There we go. Okay, so now, again, we're multiplying. Negative 2x squared times 3x squared is going to be negative 6x to the fourth power. Negative 2x squared times negative x is positive 2x cubed. Negative 2x squared times negative 5 is going to be positive 10x squared. Now, I am subtracting this thing away. Remember, usually what I do is I put parentheses around here, put a minus out in front. You don't need to do that if you just change the sign of everything. So this is minus, it's going to become plus. This is plus, it's going to become minus. This is plus, it's going to become minus. Now I can just add. Negative 6x to the fourth power plus 6x to the fourth power is 0. 29x cubed minus 2x cubed is 27x cubed. Negative 5x squared minus 10x squared is minus 15x squared. And then I want to bring down. So bring down the negative 43x. And then we're going to repeat. So I'm going to go leading term into leading term. So what is 27x cubed over 3x squared? Well, I know 27 divided by 3 is 9. X cubed over x squared would be x to the first power. So I'm going to put plus 9x. Okay? And then I'm going to multiply. So let's erase this. So 9x times 3x squared is 27x cubed. 9x times negative x is negative 9x squared. 9x times negative 5 is minus 45x. Again, I am subtracting this away. So just change the sign of everything. So this will be minus, plus, plus. Now I can just add. 27x cubed minus 27x cubed is 0. Negative 15x squared plus 9x squared is negative 6x squared. Negative 43x plus 45x is positive 2x. Now we're going to bring down this plus 10. Then we want to repeat. So I'm going to, again, go leading term into leading term. So what is negative 6x squared over 3x squared? Well, x squared over x squared is going to cancel. Negative 6 over 3 is negative 2. So this will just be minus 2 here. And then one last time I'm going to multiply. So negative 2 times 3x squared is negative 6x squared. Negative 2 times negative x is plus 2x. Negative 2 times negative 5 is plus 10. So you can see it's the same thing minus itself. That would be 0. But again, to kind of make this complete, if I'm subtracting this away, I'm going to change every sign. So this will be plus, this will be minus, this will be minus. And then if we add it here, negative 6x squared plus 6x squared is 0. 2x minus 2x is 0. 10 minus 10 is 0. So that's 0. So there is no remainder. So let me erase everything. So this is equal to that. And so again, if we want to check, you're going to take this guy, multiply by this guy. So negative 2x squared plus 9x minus 2 would be multiplied by 3x squared minus x minus 5. And I should get this long thing up here in the top, right? The negative 6x to the fourth power plus 29x cubed minus 5x squared minus 43x plus 10. So let's see if we do in fact get that. Okay, so let's begin. We have negative 2x squared times 3x squared. That's negative 6x to the fourth power. I have negative 2x squared times negative x. That's positive 2x cubed. I have negative 2x squared times negative 5. That's positive 10x squared. Then I have 9x times 3x squared. That's plus 27x cubed. I have 9x times negative x. That's minus 9x squared. And then I have 9x times negative 5. That's minus 45x. Then I have negative 2 times 3x. That's minus 6x squared. Negative 2 times negative x. That's plus 2x. And then negative 2 times negative 5 is plus 10. All right, so if I combine like terms here, I'm going to get negative 6x to the fourth power. I have a cubed here and here. So 2 plus 27 is 29. So plus 29x cubed. Then I have 10x squared, negative 9x squared, and negative 6x squared. So 10 minus 9 is 1. 1 minus 6 is negative 5. So this would be minus 5x squared. Then I'm looking at negative 45x and 2x. Negative 45 plus 2 is negative 43. So minus 43x. And then lastly, plus 10. This is exactly what we started out with as our dividend. Negative 6x to the fourth power plus 29x cubed minus 5x squared minus 43x plus 10. All right, so now let's talk a little bit about what to do when your division problem with polynomials has a remainder. So I want to go back to a problem that we would have encountered in grammar school. So something like 50 divided by 4. 50 is not divisible by 4 because when the division is concluded, you have a remainder, right? So we could say that 50 divided by 4, we'd start out with saying 4 goes into 5 once. 1 times 4 is 4. Subtracting, you get 1. Bring down the 0. 4 goes into 10 twice. 2 times 4 is 8. Subtracting, you get 2. So this 2 is known as a remainder, right? So remember kind of in grammar school, we wrote this as 12R2, right? That was the remainder. That was the leftover amount. So in other words, to kind of break this down completely, if I took 50 and I split it up into equal groups of 4, I could make 12 groups, right? 12 times 4 is 48, and then I would have 2 left over, right? So 48 plus 2 would get you back to 50. The remainder is kind of what I have left over. I don't have enough to make another group of 4. So that's how that comes about. But we learned a couple of different things that we could do. The first thing we kind of did was we put a decimal point here. We bring that up here. We put a 0, and we continue our division. 4 goes into 25 times. 5 times 4 is 20. Subtracting, you get 0. So now I know the answer is 12.5 in decimal form. But that's not really going to help us with polynomial division. The other way we could have written this, think about the 0.5 there, we could have gone back to this, let me erase all this, and said that this remainder 2, we could say plus, I have 2 that's divided by 4. Or I have 12 plus 1/2, right? 2 over 4 is 1/2. And we know that 12 plus 1/2, or 12 plus in decimal form, 0.5 is 12.5. That's exactly what we got when we continued the division. So it's legal to write it as 12 plus 1/2, or as a mixed number, right? 12 and 1/2, like that. This is how we're going to write our answers when we're dividing with polynomials. We're going to write it in that format. You'll have your quotient, plus you'll take the remainder and put it over the divisor. Now, this is very, very important. When you check your result, it's a little bit more complex. Let me erase this real quick. If I was to check the answer here, what would I do? Well, I could multiply this whole thing right here in this format times 4. So I could say 4 times 12 plus 1/2. 4 times 12 is 48. Plus 4 times 1/2 is 2. And that would get me back to 50. So I can do it that way. Another way that I could do this, I could go back to kind of 12R2. And I could say, okay, 12, the quotient times 4 is 48. Add the remainder back in, I get to 50. Right? So those are kind of two different ways that you can look at that. All right, so let's take a look at our problem. So we have 3k cubed minus 17k squared plus 27k minus 12. And I'm dividing by 3k minus 8. So again, this guy goes under the house. So 3k cubed minus 17k squared plus 27k minus 12. And we're going to divide this by, again, 3k minus 8. So I can keep writing this off to the side. So division, multiplication, subtract, bring down, repeat, or remainder. So dad, mom, sister, brother, Rover. Again, first step, leading term into leading term. So what is 3k cubed over 3k? So if I look at this, I know the 3's are going to cancel, and I know k cubed over k is k squared. So I'm going to put that over here. This is going to be k squared. Then I'm going to multiply. So k squared times 3k is 3k cubed. K squared times negative 8 is minus 8k squared. I'm subtracting this line away. So this becomes minus, this becomes plus. 3k cubed minus 3k cubed is 0. Negative 17k squared plus 8k squared is negative 9k squared. Then I bring down. So bring down the 27k. And I'm going to repeat. So now I'm going to do, again, leading term into leading term. So what is negative 9k squared over 3k? Well, this is going to cancel. Negative 9 over 3 is negative 3. And then k squared over k is k to the first power. So we get minus 3k. Now again, I'm going to multiply. Erase all this. Negative 3k times 3k is negative 9k squared. Negative 3k times negative 8 is plus 24k. Again, I'm subtracting this away, so what am I going to do? This is going to become plus, and this is going to become minus. So negative 9k squared plus 9k squared is 0. 27k minus 24k is 3k. Now I'm going to bring down. So bring down the negative 12, and I'm going to repeat. So let me scroll down just a little bit. And so again, I want to do leading term into leading term. So 3k goes into 3k. We all know that's going to be 1, right? I don't need to write out 3k over 3k. Same thing over itself is 1. So plus 1 here. And then I'm going to multiply. So 1 times 3k is 3k. 1 times negative 8 is negative 8. Now I'm subtracting this away. So this becomes minus, this becomes plus. And then look at what's going to happen. 3k minus 3k is 0. Negative 12 plus 8 is negative 4. I don't have anything else to bring down here, so I'm done. Negative 4 is my remainder. This is the remainder. Okay, so let's erase everything. All right, so I'm going to put equals, and then I have that negative 4. So I'm going to put plus negative 4 over 3k minus 8. Remember, when I divided 50 by 4, I had an answer that was 12 plus the remainder was 2, right? It was 2 over the divisor of 4. I just simplify that. 2 over 4 is 1/2, so plus 1/2. This is in the same format as this. All I did was I said plus the remainder over the divisor. So the remainder was negative 4. The divisor is 3k minus 8. Same as what I did here. The remainder was 2, and let me kind of write it as 2/4 so it's not confusing. The remainder was 2. The divisor is 4. I just had 1/2 because that's the simplified form, but I'm going to leave it as 2/4 right now. So that's how you would go about writing your answer if you have a remainder. Take the remainder, put it over the divisor, and then you're done. Now, to check this, again, it's the same thing as when you check this. You can take the quotient, multiply it by the divisor, so 12 times 4 is 48, and add that remainder of 2. That would get you back to 50. Or the other thing I could do is I can multiply 4 by this whole thing, right? So I'm going to show you both ways here, just so that we're completely clear on how to check something. So I can kind of just take this part right here and multiply it by this part right here. And when I'm done, just add negative 4, and that'll give me this. So in other words, if I took 3k minus 8 and I multiplied it by k squared minus 3k plus 1, 3k times k squared is 3k cubed. 3k times negative 3k is minus 9k squared. 3k times 1 is plus 3k. Then negative 8 times k squared is minus 8k squared. Negative 8 times negative 3k is plus 24k. And then negative 8 times 1 is negative 8. So combining like terms here, negative 9k squared minus 8k squared would be negative 17k squared. Then 3k plus 24k is 27k. And then I have that minus 8 there. So if I look at my answer here, 3k cubed minus 17k squared plus 27k minus 8, it's the same thing as this. The only difference is this minus 8 here. So why do you think that is? Again, the remainder was negative 4. So if I added a negative 4, if I said, hey, this minus another 4, this would end up being negative 12, just like it is right there, and you get your original dividend back. Now let me show you the other way. So you could also multiply 3k minus 8 times this whole thing. K squared minus 3k plus 1 plus negative 4 over 3k minus 8. Let me just kind of do this a different way. Let me go, we'll have k squared times 3k minus 8, right? I'm just distributing this to each term. And then I'll have negative 3k, or I could put plus negative 3k like that, times 3k minus 8. And then we'll distribute this again. So we'd have 1 times 3k minus 8. That's just 3k minus 8. And then let's distribute it one more time. What you'd have here is plus 3k minus 8 times negative 4 over 3k minus 8. So these two are going to cancel themselves out. It's the same thing over itself. And so I'm just left with a negative 4. So if I put equals here, let me kind of go through this. K squared times 3k is 3k cubed. K squared times negative 8 is minus 8k squared. Then negative 3k times 3k is minus 9k squared. Negative 3k times negative 8 is plus 24k. Then I have 3k minus 8, so plus 3k minus 8. And then after we canceled this, we ended up with just plus negative 4. So what you're going to find here is that you get your dividend back exactly. So 3k cubed, negative 8k squared minus 9k squared is minus 17k squared. Then 24k plus 3k, that's plus 27k. And then negative 8 plus negative 4 is negative 12. So I get 3k cubed minus 17k squared plus 27k minus 12, which is exactly the dividend that I started with.